My name is Ajay Chabria, and I'm a product manager with Oracle Cloud Infrastructure, focusing on building a managed Kubernetes offering called as Oracle Kubernetes Engine, wherein we help enterprises, developers, organizations to move their microservices-based applications onto OCI. So if you are looking to run your applications in a containerized infrastructure, or you're trying to break down your monolithic-based application into a cloud-native-based application, or you want to really accelerate your software delivery process or increase your agility for your business, or even improve your user experience, this session would be for you. In this presentation, you'll see how enterprises are already doing that by reducing their deployment time to minutes, increasing their performance, what they would really get in an on-premises environment, and just paying for the price that they are just using the overall managed Kubernetes. So with widespread adoption of containers among organizations, Kubernetes, which is the container-centric management software, has become the de facto standard to deploy and operate containerized applications. Gartner predicts that by 2024, 75% of the enterprises or organizations across the world will be using containers in production or even using Kubernetes in production. And they predict that the number would spike up to 90% by 2027. So we all know containers and Kubernetes is the way to go about it. But the number one challenge for adopting Kubernetes is the complexity of managing it at scale. And that is exactly where managed Kubernetes comes in for users, for developers, for enterprises to run containers and orchestrate them and also eliminate the complexity. So let's take a step back and understand what is Kubernetes. I recently asked one of my colleagues here in Oracle to tell me what she thinks about Kubernetes in just one line. And this is what she had to say. She mentioned that it is an open source platform which is production ready. So we all know that Kubernetes is an open source distribution. But the beauty of Kubernetes is that somebody who wants to use Kubernetes can use that distribution, and they don't have to write any additional code to make it production ready. It is at a stage today that one can simply just deploy their application and put it in production. So let's try to understand the Kubernetes architecture using an analogy of a ship. So the architecture you see right here, it relates to the cargo ships, right? So the worker node on the right in the cluster are the ships on which you can load your containers, right? But there has to be somebody that needs to load the containers on the ship, and not just load, but also plan like how to load them, also identify the right ships, store the information about the ships, monitor and track the location of the containers in the ships, and manage the entire loading process, right? And this is done by the controller ships on the left that host different offices, departments, monitoring equipments, communication equipments, cranes, for moving those containers between ships. And that controller is nothing but the control plane or the brain of the Kubernetes architecture. So let's try to now see what the actual architecture looks like, right? So in this architecture, you see on the left, you see a cluster control plane, which has the API server, the cloud controller manager, the kube controller manager, and even the etcd, right? And even the scheduler, right? So to begin with, the API server, right? The API server is responsible for authentication and authorization. So every call that you make onto the Kubernetes, it really goes through the API server. Kube Controller Manager, on the other hand, is responsible for seamlessly integrate the cloud provider's API with this Kubernetes. So let's say if you want to use a load balancer or any storage offering by any cloud provider, you can seamlessly use it using the Cloud Controller Manager. And the Kube Controller Manager, on the other hand, is responsible to make sure that the entire cluster is working the way it should work. It's responsible for controlling some sort of controllers like node replication controller or node controller to make sure that the entire orchestration is working the way it should work. And The kube scheduler is basically responsible for scheduling the application, maintaining the application's desired state, scaling the application, and even rolling out new updates. And then lastly, but not least, the HCD. The HCD is responsible for storing the entire cluster's configuration, right? So the node or the worker node on the right, like you can see, it is where your applications are really deployed. That is the place wherein you as a user would really work towards just writing your code and deploying your applications. So this is overall how a Kubernetes architecture really looks like. So now that we understand the architecture, let's try to understand what are some of the Kubernetes challenges that enterprises and organizations are going towards that is really stopping them from adopting Kubernetes. So this is a survey done by CNCF. CNCF stands for Cloud Native Computing Foundation, which clearly shows that more than half of the organization right here, they're seeing the top challenge in managing the Kubernetes environment to be the lack of skills and experience, right? Then followed by security and compliance. So, like we already know that there are organizations, there are enterprises that really want to work towards adopting Kubernetes, but they are not really investing the effort or putting any efforts to train their employees in learning about Kubernetes, and they still stand with having a monolithic based application in their production environment. On the other hand, there are organizations like banking or financial customers for whom data security is really the key. They are reluctant to move towards or making any changes to their monolithic based application because they think that it would really impact their data security, and it would really take them a lot of time to come into production when they transition into Kubernetes. And then the most important point here is the complexity of deploying it, and that is exactly where managed Kubernetes comes in, because for organizations that really take a step towards going and taking over using Kubernetes, they really find it hard and complex to make sure that they have the right set of integration of things that they really make it into production. So that is where the complexity piece comes in, and that is exactly where managed Kubernetes comes in to eliminate that complexity. So as you can see, there is another survey on the top right, done by VMware, which clearly indicates that the number of enterprises, or the percentage of enterprises that are using self-managed Kubernetes cluster or do-it-yourself Kubernetes cluster, has been reduced from 29% to 18%, and the number was a little more lower in the survey of 2022. So this clearly really shows what are some of the challenges that really stops enterprises to go ahead with Kubernetes. And that is exactly where managed Kubernetes comes in, right? So managed Kubernetes mainly is a service that is responsible for managing the control plane, like you saw in the previous architecture diagram. But also some of the managed Kubernetes offering, they also gave an option for enterprises, customers, developers to allow them to also manage the infrastructure of the worker nodes, so that they don't have to really worry about many management tasks like provisioning the servers, operating system updates, and so on, right? That is what we, as a service provider, in this example, I want to use Oracle Kubernetes Engine as an example, because we are also a managed Kubernetes service provider for users who really don't want to manage their infrastructure of Kubernetes. We can do that for them, right? And it also helps towards agility, right? Let's say if you want to really move your Kubernetes based infrastructure from your on-premises to cloud, right? We provide the API. There are consoles wherein you can quickly come and deploy. It's not something that you have to really worry about. If do I have the right server? Do I have the right virtual machine? Do I have the right infrastructure in place? You can just plug and play. So there is that really helps towards increasing your business agility, right? You don't have to be really thinking like about other sort of logistics to get started. And then security is something that we really take seriously across being as a managed Kubernetes service provider. So when we talk about security, right, we provide security not just at the control plane, but across the board, even for the data plane. So you don't have to really think about is my application being secure, right? That is something that we, as a managed Kubernetes service provider, we kind of help you with that. And lastly, but the least, we as a managed Kubernetes service provider, we don't really change the distribution what the community provides, right? We just wrap things up or provide a wrapper around what the distribution has been released in the community. We take that open source distribution and we just wrap things up with our services that we can provide as an Oracle service provider. So we really not just take that, but we also make sure that if you want to really use other cloud services like load balancer storage, you have that all facility, right? It's not that Oracle just offers a single service called as Oracle Kubernetes Engine. There are other services as well that you could also seamlessly integrate and use it with OKE. So when customers are running their application, right, they have to run on some server, right? So this slide really talks about what are some of the operations that one has to go about when they're using a self-managed Kubernetes versus what of these tasks can be offloaded by a managed Kubernetes service provider. So like I was mentioning, when customers are running their application, they have to run it on some server, right? And the question is really who is responsible for provisioning and managing those servers, right? So when it comes to managing the servers, it is not a one-time thing. It is something that you have to do on an ongoing basis as long as your application is running. So there are things like patching the operating system, updating the security updates, repairing the nodes when they go down. These are all the things that customers are responsible for, right? And as your application grows, these tasks become more challenging and complex. But let's say if as a managed service provider, you don't have to really focus on taking care of these tasks. That is where you could offload all these tasks to a service provider, right? So that way, you as a customer just simply focus on building your application, right? And the most important thing that I forgot to mention is that as a managed Kubernetes service provider, we also ensure that you are always up to date on Kubernetes versions, right? You don't have to really worry about whether my Kubernetes is giving me all the latest features that the community is offering, right? We really ensure that you are working in par, you are moving in par with whatever versions are released in the community. And we as a service provider always keep you up to date and also give you an option to simply just update your version with just one single click of a button. So let's try to understand where does managed Kubernetes fit in, right? So as I was mentioning in my previous example, you as a developer could run your Kubernetes on a bare metal or a virtual machine, right? Or do it things yourself, or even you could use your cluster API to manage like multiple Kubernetes clusters, be it on premises or on cloud, right? So that is where you get like more control. You get more control of the infrastructure. You get more control of the environment, right? But let's say if you as an organization or you as a developer want to really move from one cloud to another, right? That is where there is no agility left in place. So that is when you start to think that, okay, fine, if there is no control, I could still be try to focus on building my applications and not really worry about the infrastructure. So that is where you would start thinking about, okay, fine, maybe I could try to use OCI functions, right, to simply just focus on the code, and get a serverless experience. But there is no control on the infrastructure, right? That is when although you get more agility, but there's no control. And that is exactly where managed Kubernetes comes and fits in, where it gives a good balance between control and agility, wherein you could decide really what pieces of things you want a service provider to control. And we also offer the facilities that gives you more agility, right? That is where you are not really bound to either go with functions or you want to do it yourself. You get that mixed balance of things that helps you decide what you want to really take a control on. So let's try to understand um, what are some of the benefits you really get by using a managed Kubernetes offering. So on the top left, I was already mentioning about built-in management, right? Wherein you as a developer can decide what you really want the service provider to control, whether be it a control plane or data plane or both. You don't have to really worry about scaling, right? You don't have to really worry about how many servers you need to deploy or how many servers you need to buy beforehand in order to deploy the application. You just decide on the number, and based on the quota, you can achieve the scaling you really want, right? And you can simply move from one Kubernetes version distribution version number to another distribution version number without making sure, without disrupting your really environment, your production core, right? We make sure that any upgrades that you go from one Kubernetes version to another really is non-disruptive. Now coming on to the open standards, right? So CNCF, or Cloud Native Computing Foundation, it runs a conformance program that makes sure that the cloud provider's API is really aligning with what what API the community really offers. So we as a cloud provider, we are not really writing a new APIs for Kubernetes distribution, right? Which really allows users or developers to not really stick to one cloud, but from to even have a multi-cloud presence. So you don't have to really be logged into a specific vendor. You have that choice to move from one cloud to another, or have footprints towards multiple clouds. There is also another Open Container Initiative compliant, which makes sure that the runtime and image registries are also following the standards, right? So we as a cloud service provider, we are not really providing our own standard formats, which would really lock you as a developer to a specific cloud provider. So we provide all of that. We make sure that all of that is being followed. And not just that, you could also extend your Kubernetes cluster to other cloud services like load balancer storage and even CI/CD capabilities that we as a cloud provider already supports. And then you really just pay for the price you use. You don't really pay anything upfront, right? That is where the price and performance is also like something that you really just pay for what you use. And like I was mentioning, you don't have to really worry about installing the use the kube admin tools. You could just spin up your cluster in minutes and achieve what you're really wanting. And we as a cloud provider, we also make sure that everything is highly available by default. So let's say if you're launching a Kubernetes cluster, we give you that option whether you want to really distribute your workloads from one availability domain in a specific region to another availability domain, right? So let's say if there's a multi-AD region, we'll make sure that the control plane components that get launched are fairly distributed across availability domain in a single region, right? And the same goes with the worker nodes where your data plane would offer. So let's say for some reason there is a downtime, we will ensure that your service is always available, based on what region it is. And lastly, but not the least, we make sure that we provide all the security benefits like encryption is enabled by default. Every images are scanned and signed, so there is no vulnerability within the image. With stick-based hardening, we make sure that you cannot just only run your commercial workloads, but you can also run government-based workloads if you have any. And we also give option to make your clusters private, and even so is the registry. So let's try to see how would the Kubernetes architecture that we understood in our previous slides, how does it look like in a cloud world, right? So in a cloud world, you as a user, you don't have direct accessibility to a cloud provider's infrastructure. You as a cloud provider only have access to the infrastructure in a form of a tenancy, right? So you are a user. If you are a user, you are a tenant in the cloud world. So as a tenant, the first thing what you do is you create a VCN. And VCN is nothing but a virtual cloud network. It's a networking construct in OCI. So once you do that, basically you define what would be your CIDR block, IP address block, and where you want your Kubernetes components to sit in, right? So you need to really think about the IP address planning for API endpoint. your load balancers, and your node pool type, or your compute instances, which would be acting as a worker node, wherein on which your application will be deployed. But you as a user, you don't really focus on the control plane components, and this is a scenario wherein you are asking the cloud provider to manage the control plane component, right? So you don't really worry about where my control plane components would fit in, right? That is where you just come in, spin up a Kubernetes cluster, and everything gets configured for you automatically, right? So you don't really have access to the control plane components. You just really focus on what you as a user could see is you will be able to see the API endpoint, the load balancer or the ingress, or the compute instances. And that is where you start going at and just deploy your application, and then your users would directly just talk to the load balancer right here, or any ingress endpoint, right? So as in this scenario, you don't have to really worry about control plane. It will be automatically scaled, it will be automatically up to date, but you as a user have to still think about updating the infrastructure of the worker nodes on the right? So that is where you have to make sure that the worker node is up to date, the operating system is up to date, and that would be something that you own. But let's say you want even that portion of the infrastructure to be managed, then we also have an option as a service provider to manage that for you. That is when you would say that you want the service provider to just also manage the control, not just the control plane, but also the data plane as well. So that way you just focus on the Kubernetes component on the top right blue, right? Wherein you just focus on the pods, services, persistent volume, and so on and so forth. Whatever underlying infrastructure that is required, we do that, all the actions for that, and you just really pay for what you really use. So this mode would just give you a serverless Kubernetes experience, wherein you don't really, although using a managed Kubernetes offering, but you have infrastructure in place, but you don't really worry about the underlying components. That is where we manage things for you, and you could simply just focus on building an application, and think about integrating with other services based on your application requirement. And this is how the architecture would really look like when you go for the control plane and the data plane aspect. So in the tenancy world, like I was explaining, you as a user in this case would not really have access to the compute instance. You as a user would only be access to a virtual NIC or a virtual network interface card. That is where you would simply really talk to. There won't be any infrastructure, there won't be any compute instances that you would be seeing from your tenancy when you log in, because that is something that we on the left, we do that management for you. You just get an access to the endpoint. That is exactly what you just focus on, and you just as a user simply run those kubectl commands to that particular endpoint. Now, this is an example wherein you could also achieve like integration with other cloud services. So in our case, in case of Oracle Kubernetes Engine or a managed Kubernetes service provider, we also integrate with other services to provide like a rich platform with comprehensive set of features for cloud native application development, right? And these include core services like our innovative computing, our networking platforms with support for flexible compute shapes and load balancers that really make your scaling easy and transparent, right? And then you could also achieve governance and security by making your systems fully auditable and observable, right? Customers can also manage their encryption keys using the vault services that we offer in OCI. So you could also seamlessly integrate with developer services like DevOps that really provide Git repositories, build and deployment pipelines that can support blue or green and canary deployments to your Kubernetes environment with traffic shifting policies. And so overall, basically, you could seamlessly integrate, not just use OKE in a cloud, but you could also seamlessly integrate with other cloud services that like you see it here, right? So basically, the choice of technology stacks and tools are completely open. Just because there is a seamless integration that is offered, that really doesn't mean that you have to really go with that. We don't really deny a user from not using the open source tools and technologies if they want to really use that. So lastly, I just want to wrap things up with some of the customer success stories we have had in Oracle. I want to talk about two business challenges. The one on the left is about a customer on which thousands of leading brands really rely on this customer uh, for their proprietary artificial intelligence and machine learning capability to learn how consumers really think and feel what they would really buy, right? And and the reason was these companies' demand really grew because these leading brands were going through a lot of churns, which really wanted them to decide, make use of this artificial intelligence capability to decide what their really consumers would really, go for or buy for. And as these companies' business challenge really grew, it really needed a significant upgrade from their on-premises infrastructure, right? And that is where this customer of ours, they tapped onto Oracle Cloud because we offer the best performance and at a reduced cost. We also have a global data center footprint, right? So Oracle Cloud offers services from 41 public cloud regions in 22 countries. So we got this customer moved from on-premises to public cloud into our cloud in just a couple of months, and they were able to achieve significant performance improvements and also achieve like easy scalability. And now once they were in OCI, they were able to successfully use that particular customer's intelligence software. And now their customers or leading brands are better equipped to understand how the consumers really think, and eventually work towards decreasing the churns and sharpen their decisions that really impacted their revenue. Then there was another customer on the right. It's a tele video conferencing customer. Uh, as you all know, after Corona, video conferencing became the standard for remote working, customer engagement, distance learning, and telehealth. And this customer really needed to hyperscale quickly to demand support while also stemming its soaring cloud computing cost. And to accommodate for its increasing traffic of probably 2 million active monthly users and 1.5 petabytes of data incoming per day, this customer really needed a cloud provider that could support the exponential growth of its free video meeting services, right? So this customer was already in another public cloud, but we were able to move them from that public cloud to us, without changing the customer's application in just a matter of 4 days. And now the customer now like provides valuable meeting services to millions of the customers all over the world, including schools, hospitals, and everywhere. And they were also able to increase some performance per node compared to the other cloud that they were earlier in that. And we were able to reduce their cost, just 80% of their network egress cost, and successfully increase their users from 150,000 to 2 million. So these were some of the customer success stories that we have had at Oracle. So lastly, just wanted to summarize it with the slide, whether it's time for you to decide. You probably got an idea on how things can get complex once you're using a self-managed Kubernetes cluster versus how you could ease your complexity by leveraging a managed Kubernetes offering that is being there, that has been offered. So it's time for you to decide which one would be good. I did not really wanted to influence anyone's decision by this talk, but I hope this gave you a good overview and it would help you really for decision making. And if you are really having a phone in your hand, I would just want you to just open your camera and maybe scan this Bitly link that would uh, help us to get connect with you guys. So there's the first link on the top right is the link to the Slack, when you could connect with us if you're already in OCI, already using OKE, wanted to connect to us with some issues, you want to troubleshoot something, or you want to share a picture of your pets, just come us and talk to us. Or there's another link on the bottom right, which is a one-stop shop for a lot of technical contents and reference architectures that we have in Oracle. So if you want to really understand how users, developers, and organizations are using Oracle Kubernetes Engine, if you want to refer to any architecture, this would really give you an access to that. And if you're not in OCI, you want to try using Oracle Kubernetes Engine, there is a way you could do it for free. You could scan the bit.ly link that is there on the left. And then the other bit.ly link is basically would tell you about any upcoming events that we have for the developers, whether those events are in person or virtually. You would get an idea. You could scan this particular bit.ly link. And lastly, we will be having an Oracle Dev Live event in Oracle Redwood Shores in person from March 28th to March 23rd. There'll be 4 tracks that will be focusing on. It would be focusing on Java. It would be focusing on cloud native and AI, Oracle database, and MySQL. So if you want to really tap on to the conversations and meet other developers, it's a free event. There's no cost to attend it. So you want to just scan this particular bit.ly link and be present, whether virtually or in person. And looking forward to see you guys again. It was nice talking to you, and thank you, everyone. I hope you all are having the rest of the day.
All right. Thank you, AJ. We'll be back on the stage in just a minute.